is not their individual reciprocal. It's not how you get the reciprocals of two parts. So don't even think about reciprocating that bottom fraction. It doesn't work. So here's what I got to do. Here's your steps you're going to write down. Number one, find common denominator. From all the denominators. So I check out all my denominators and come to a conclusion about what would be a common denominator. I got two denominators, right? They both happen to be x. So what's the common denominator going to be? It's just x. So the common denominator is x. Everybody see that all right? Step 2. Multiply top and bottom, numerator and denominator, by the common denominator, which happens to be x. Now, if I'm multiplying top and bottom of this fraction by x, what am I actually multiplying by? 1, right? Just multiplying by 1. So I'm not changing the fraction. I'm just changing the look of it. Hey, I got two parts here. I got two parts there that I'm multiplying by x. What property? Distributed, right? So I have to multiply the x times the 1, the x times the 1 over x, the x times the x, the x times the minus 1 over x. Okay, here we go. X times 1, that's easy. X plus x times. Okay, now here's an important question. When I multiply x times the fraction 1 over x, which part of that fraction do I multiply the x by? The top, the bottom, or both? Let me go for top. You're absolutely correct. Okay. So I just multiply the x by the numerator. So I get x times 1 over x, I get x over x. Same thing in the denominator. X times x is x squared, minus, in this case, x times 1 over x is x over x again. And here's where you're thinking, we didn't make any progress. We still have fractions in our fractions. Oh, yeah? What's the word? X plus 1. Aha! That's why we did it. Over x squared minus 1. No more fractions in our fractions. Just a simple, harmless, housebroken, domesticated fraction. All right? Here's a regular old fraction. So you through? You probably think I've done enough, haven't I? That's right. Did everybody recognize the difference in two squares? Cancel out the common x plus 1. Don't forget x minus 1 is in the denominator, so keep it here. Okay? Let's work one more like type 2, okay? See, it's the denominator that makes this a type 2 problem, right? Got fractions in my denominator. So I take the steps. First thing is to find what? Common denominator. I check out my denominators. What's going to be my common denominator? 4x. If I see that all right. But my denominators are 1, 4, and x. So my common denominator is going to be 4x. And then what do I do with 4x? Multiply Top and bottom by the 4x, absolutely. So multiply upstairs and downstairs. Okay, to multiply 4x times this fraction, I multiply it, you already told me, by the numerator. So 4x times x is 4x squared minus 4x times 4 is 16x. So multiply 4x times this fraction, I multiply by the x. 4x squared over 4 minus 4x times 4, it's 16x over x. Are we okay so far? This does not need to be over 1. It's fine as it is. 4x squared minus 16x. Here's where I'm glad I multiplied by the 4x because my denominators are going to disappear. The x squared minus x has disappeared, 16. You think that might simplify? We're about to try. How do I simplify the numerator? Are we in? Of what? 4x. Okay, take out a common factor of 4x. That leaves what? X minus 4. Denominator?
X plus 4.
Very good. Difference of 2 squares. X plus 4, x minus 4. That's why we factor. There's the common factor. It's out of here. Hey, by the way, just a little review here. What's the domain of this expression right here? In other words, what can x be? All real numbers? Except for negative 4. Because negative 4 makes the denominator 0, right? Remember that, right? Very good. Okay? All right, we're going to fling ourselves wildly into the next section.
Next section. What's going on in the next section?
In which we introduce this fellow right here. The link to the next section is called the rectangular coordinate system and graphs. This guy right here is called the rectangular coordinate system. You can probably tell why. It's just full of rectangles, right? I mean, there's rectangles everywhere you go. It's also called the Cartesian coordinate system, after its designer. Somebody know who came up with this guy?
Rene, I don't know how to say his last name. C-A-R-T-E-S.
Okay, Rene. It looks like Descartes for those of us in the East Texas. Those French are crazy to say it Descartes, all right? So it's Rene Descartes. Anybody have the philosophy yet? Did you encounter Rene Descartes?
Yes.
Rationalist. What was his famous saying?
I think, therefore I am.
I think, therefore I am. He actually came up with that statement to pick up girls at parties, but it didn't work, so he donated it to the philosophy department. Little known fact. All right, so Rene Descartes, inventor of the Cartesian coordinate system. You're familiar with this guy. Its major parts. These two guys, these two bold lines are called the x-axis. You familiar with that? And the y-axis. They cross at a strategic point known as the